Hey there, and welcome. Ever feel like math is just a series of locked boxes? Well, what if I told you there are secret codes, special keys really, that make unlocking those boxes surprisingly easy? Let's get started. I'm serious, just think about it. What if you had a set of keys that could simplify, rearrange, and solve stuff that looks really complicated at first? Because that's exactly what we're doing today. You're about to get a kind of mathematical superpower. Okay, so think of this little puzzle here as our first locked box. Some problems look easy, some look tough. But inside every single one of them are clues that point us to the fundamental keys of math. Let's start the hunt. All right, so let's grab our first set of keys. Now, I like to call these the do-nothing keys. But don't let that name fool you. Their power is actually in their simplicity. In the math world, they're known as the identity properties. So first up, we have the additive identity. And it is incredibly straightforward. All it says is if you add 0 to any number, that number stays exactly the same. It keeps its identity. It's like a key that turns on the lock but leaves the door just as it was. So the rule is as simple as it gets. For any number, we'll just call it a for now, a plus 0 is always going to be a. It looks almost too simple, right? But trust me, this little rule is a workhorse. And guess what? It has a twin, the multiplicative identity. It's the exact same idea, but for multiplication. Any number you can think of, when you multiply it by 1, stays the same. Another do-nothing key that really helps us simplify things. And yep, the rule looks just as clean and simple. A times 1 always equals A. You're about to see just how handy this is. Okay, let's go back to that first puzzle and unlock it. We start with 3 times 1 plus 8 plus 0. The first thing we do is look inside those parentheses. That's 8 plus 0. Well, using our additive identity key, we know that's just 8. Easy. So now our puzzle is simpler. 3 times 1 plus 8. Next up is the multiplication. 3 times 1, and our multiplicative identity key tells us that's just 3. And look at what's left, the final unlocked problem, 3 plus 8, which is, of course, 11. See? Those keys just cleared out all the noise. All right, you've got the do-nothing keys down. Let's level up. Our next set of keys is all about moving stuff around. These are awesome because they literally give you permission to reorder and regroup numbers to make your life way easier. Now, these two can be a little tricky, and people mix them up all the time, but they have totally different jobs. The commutative property is all about order. Think of the word commute, like moving from home to work. It just means you can swap the order of numbers, and the answer doesn't change. Then you have the associative property. This one is all about grouping. Think about who you associate with. It lets you change which numbers you group together first with parentheses. So the big difference, commutative swaps positions, associative regroups without changing the order. So this is awesome, right? We can just shuffle numbers around however we want. But hang on a second. Does this work for everything? Like, what about subtraction? Can we just regroup things there too? You know what? Let's put it to the test. Let's see if we can change the grouping, the association with subtraction. Is the result going to be the same on both sides here? And here's the reveal. Let's do the math. When we solve it the first way, 19 minus 8 minus 5, we get 11 minus 5, which is 6. But when we regroup it the other way, 19 minus 8 minus 5, that becomes 19 minus 3, which is 16. And yeah, 6 is definitely not 16. This is a huge gotcha moment, and it's a super important rule to remember. These awesome reordering keys, they only work for addition and multiplication. So far, we've got keys for simplifying and keys for reordering. But now it's time for the master key. This one doesn't just simplify or reorder. It breaks expressions open in a whole new way. Let's talk about the distributive property. So what does this master key do? Well, it lets you distribute or, share a number that's being multiplied against a whole group of terms inside parentheses. You're basically handing it out to everything inside. Here's the blueprint for how it works. If you have a number A multiplied by the group B plus C, you just distribute that A to everyone inside. It becomes A times B plus A times C. You've basically busted the parentheses right open. Let's watch this master key do its thing. We've got 4 times P plus Q. First, we distribute that 4 over to the P. Bam, you get 4P. Then we do the same thing with the Q. We share the 4 with the Q and we get 4Q. The lock just pops open, and we're left with our new expression, 4p plus 4q. So clean, right? Okay, we've collected our keys. We have the identity keys for simplifying, the reordering keys, and now the master key. It's time to put them all together and crack one last code. Here we go, 6t plus t. Now, this looks super simple, doesn't it? But how do you actually combine them? It's a bit of a head-scratcher until you remember the keys you're holding. Okay, let's walk through this one. First, that lonely t at the end. It looks like it's by itself, but our multiplicative identity key tells us that any variable is really 1 times that variable. So we can rewrite it as 6t plus 1t. Now, for step 2, look closely. Both terms are being multiplied by t. This looks exactly like the answer to a distributive problem. So we can use our master key, but in reverse. It's a really cool move called factoring. We pull that common t outside the parentheses, and what's left inside? Just 6 plus 1. And for the final step, the final turn of the key, we just clean up what's in the parentheses. 6 plus 1 is 7, and we get our fully unlocked expression, 7t. And there you have it. By combining our keys, we took something that was a little tricky and found the simple, clean answer hidden inside, 7t. You know, there's this great quote from S. Scudder that just hits the nail on the head. It says, "The whole point of math isn't to make easy things hard, but to make hard things easy." And that's exactly what these keys do. We've really just scratched the surface today. Now that you have these keys, identity, commutative, associative, and that amazing master key, distributive, just think about it. What other tricky, locked problems out there are just waiting for you to come along and solve them?